Good morning, dear students. How are you all? All doing good? Good morning, very good morning to everyone. We are in the process of understanding this concept of portfolio management for the CA final Advanced Financial Management paper. And we have covered a good quantum of concepts and the questions from the topic of portfolio management. So initially we started with calculation of the expected returns of a single security and measurement of the risk of a single security by calculating the standard deviation. Then again, expected return and standard deviation was calculated on the basis of two different ideas, where one was taking a probabilistic scenario into account. The other was based on historical outcome, or based on the historical data. Then we started with the discussion about portfolio returns and risk, where we found that portfolio return can be simply weighted average of the individual security returns. But when it comes to standard deviation of portfolio, that doesn't work like that, because there is another factor which is playing a role, which is the correlation factor. Okay, so correlation was understood. So we first learned something about the correlation, which is covariance upon the standard deviation of both securities. Then based on that covariance and correlation, when we tried to create a Markowitz portfolio formula, we found that we were actually able to calculate the standard deviation of the portfolio. Right. So basically, Markowitz formula was weight of x square into standard deviation of x square plus weight of y square into standard deviation of y square plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y, and the correlation between x and y. Okay, now you can definitely modify this formula according to the correlation, and moreover, this last three terms, which is standard deviation and correlation, can be combined and simply stated to be the covariance. Then we understood how the portfolio risk and return curve appears for different degrees of correlation. So if the correlation is +1, then the line is simply a straight line. If it's -1, then there is a possibility that you can reduce the risk to lowest level, which may be also 0. After that, we learned something called as a minimum risk portfolio formula, which was standard deviation of y square minus standard deviation of x, standard deviation of y upon into correlation of x and y, divided by standard deviation of x square plus standard deviation of y square minus 2 times of the both standard deviations multiplied with the correlation. Then we discussed few of the questions, and then we went ahead with the Markowitz efficiency frontier. But before that, we understood what are the efficient and inefficient securities. So basically, inefficient securities are the securities in which case, if there is some other security which provides higher return at a lower risk, or higher return at the same risk, or same return at a lower risk, then we say that the security is inefficient. And the collection of all those efficient securities was actually helpful in creating something called as efficient or efficiency frontier. Okay, then after that, we went to the other side of the market, where we said, what would an investor really require? An investor will definitely be requiring utility when he or she is investing into the market. 3 types of investors we looked at. So risk averse, risk neutral, and risk averse. So Markowitz portfolio theory is only for the risk averse investor, because they are the rational persons who are ready to invest in a risky security, provided they are adequately compensated with a higher expected return. And the utility was defined as expected return minus half into aversion factor into variance. Now, that aversion factor, we stated ranges between 1 to 5, and then we matched the utility curve with the efficiency frontier, with the tangency being the best portfolio that was allocated to the client or to the investor. Then we simply went ahead and understood that it's better to create a portfolio comprising of risk-free security and the securities on the efficiency frontier that gives us a more efficient portfolio as compared to what we can observe on the efficiency frontier. So that line was called as a capital allocation line. And as the market shifts towards the capital allocation line, that same line becomes capital market line. And we found that this particular line was a portfolio of the risk-free security and the market portfolio. And we also computed the required return of a portfolio under capital market line, which is risk-free plus standard deviation of portfolio upon standard deviation of market into RM minus RF. Now, definitely this was not the beta. So we went ahead with the CAPM, where they are under an assumption that when you are into an efficient market, you will be obviously looking for minimizing the risk by creating a diversified portfolio. So the diversified portfolio will be helpful for you to reduce the risk, but not to zero, because you still have to take some amount of systematic risk. And since the markets are assumed to be efficient and investors are supposed to be rational, they are supposed to be creating a combination of combination of securities where they would ensure that portfolio is adequately diversified, and definitely they will be compensated only for the systematic component. And that systematic component or risk was measured by beta, which was simply standard deviation of security upon standard deviation of market. You multiply it with the correlation between security and market, so that you are compensated only for the proportion of the systematic portion of the total risk, right? And we saw a few other formulae for calculation of beta also, which was covariance upon the variance of market, and then the derived formula were as follows. Then we did few questions on calculation of beta and some questions on the KPM, or the KPM was also called as the securities market length. So that is what we have covered till now conceptually. Now let's go for two more concepts, the last two models that we have. One is the Sharpe's single index model, and then we have the other model, which is arbitrage pricing theory. Okay, now let's begin with something called as Sharpe's single index model. Okay, so let me just help you with this Sharpe single index model with a question, so that we'll be able to do the question as well as the concept will be done with that. So let me take up the question. One second. This is, I think, yeah, question number 12. So we are looking at this question 12. The rates of the return on the security of company X and the market portfolio for the last 10 periods is given. So we have to calculate the beta and something called as a characteristic line of security X. Now, characteristic line is nothing but the model which has been suggested by Sharpe single index. Let me first take down the data over there. So we have like return of security X and the return of the market. Okay. Now the data is like 20, 22, 25, 21, 18, minus 5, 18, minus 5. Let me just do one thing. Let's keep the calculation a bit crisp. So let me just take this 11th question, guys, because this also will serve the purpose. So we don't want to get lost in the calculation. Yeah. 12, 15, 11, 2, 10, and minus 12. Okay, and then we have the return on market portfolios for the same corresponding period as 8, 12. Then we have 11 minus 4, 9.5, and minus 2. Okay, so these are the returns that we have got for the security and the market. Now, what is this sharp single index model really talking about? And what are we really thinking from the point of view of characteristic market? Do we guys remember the concept of regression? Do you remember the concept of regression from our CA foundation days, or maybe from your 11th standard or 12th standard? And some of you might have even learnt in your college days, like in your graduation. Do you know something called as regression? Yeah?
Yes, it's a regression on X on Y and Y on X.
Regression of X on Y, Y on X, correct. So regression was basically trying to, fit a particular equation for these two things. Like if I take this X and the market, so market is supposed to be the independent variable, and this security X is, or let me name it as A, or security A is a dependent variable. So what do we really do in regression? What is the, the task that we try to do in regression? So we, first, let me just show it to you what a scatter plot would, literally look like. So this is what the scatter diagram really looks like, right? So the relationship between the security A and the market, that's how this scatter diagram looks like. What regression tries to do is, it tries to form a line. It tries to form a line such a way that the line should be fitting somewhere, in between this diagram, right? So in between this diagram, maybe which should be actually a representative of the trend of the pattern of A and B. So maybe the line may be this one, or it may be this one, or it may be somewhere over here. But by mere observation, what we can say is the line should be, somewhere, sir, working out to be like this, which should be, representative of the entire trend of the return of A with regards to the return of B, or return of the market. So our idea over here when we are doing regression is to calculate this particular equation of the line, right? What do you understand by the equation of the line? How do we compute the equation of the line, guys? What is the equation of a line? How do you calculate the equation of a line? Or general form of equation of the line? Have you learned something called as y equal to mx plus c? Right? Y equal to mx plus c, where m was the slope of the line and c stands for the constant. Right? So C stands for the constant. So Y was the dependent variable, X is the independent variable, and we're trying to fit a equation in between both, so that we'll be in a position to make a particular regression line. Okay. Now let's look at the process for how do we mathematically carry out this, obtain this particular regression line. Because graphically I've tried to to the best possible explain you what are we really trying to do. We are trying to form a line like this, which should be representative of the overall data point. Okay, now how do we do it mathematically with all set of formulae? Let's have a look at it. So the first thing is, when we are looking at sharp single index model, my idea is to create a characteristic line. Okay, my idea is to create a characteristic line. So first we need to get the slope. And slope is nothing but the beta of the security A. Now, before we go for getting the beta of security A, we need to compute the average market return. Now, average market return will be, of course, we take a sum of this entire market return. Right. So, average market return will be like 34.5 divided by what is the number of terms that we have? 1, 2, 3, 5, 6. Right. So, I can say this is like 34.5 divided by 6. So that should give us the average market return to be 5.75%. Whereas if we calculate the average security return will be on the similar lines, which is taking like total is 38, we divided by 6. So that's like 38 divided by 6, which is 6.33. Okay, so average security return is 6.33. Okay, and average market return is 5.75. So market return is like 8, 12, 11 minus 4. These are numbers are given, and even security returns are given. So we computed the average return. That is the first step that we do while calculating the regression. Okay, that's the first step that we do while calculating the regression. Second step is to calculate, the beta or the slope of the line. So to compute the slope of the line, we have to use beta formula. Now, how do we really go about, calculating the beta? Okay. Now, beta can be computed. We have seen the formula for beta. Beta can be computed simply as, summation of mx upon and n summation ma over here. So we'll use the same formula for beta, which we have revised over here, like n into summation sm minus summation s into summation m upon n into summation m square minus summation m the whole square, which is nothing but a derived form of covariance of sm upon variance of sm. Now, I will not be preferably using this formula because, s minus s bar, m minus m bar, that will be a bit problematic because already we have these decimal numbers. So let us solve the beta, or let's try to get the beta by the equation by this particular form. So this is like we have n and m and a. So this will be, beta will be computed as n summation ma okay, minus summation of market return into summation of a, the whole divided by n summation market return square minus summation m the whole square. Right, so we'll be using this formula to get the beta. So we need to add a few columns over here to get the value of beta, guys. Right, so we can get the beta value by simply looking at, we already have the m and a values. What we need is m into a. So we get the m into a values. Okay, then we also need summation m square. So we'll need m square. Right, so let's compute the values, m into a and also m square. So we take a total of this. Okay. Right, so I'm giving you the total numbers, which is summation m is given, summation a is given, summation ma is given, summation m square is given. Just substitute in this formula and give me the beta, guys. Please do the calculation and give me the beta. Substitute these numbers into this beta formula and give me the final beta value, guys. Give me the final beta values. Yep. So n will be 6 into summation ma 508 minus summation M summation MA minus summation M multiplied by summation A. That's the numerator. Denominator will be like 6 into summation M square minus summation M the whole square. So it's 1445.25. And then when we solve it, just verify, guys, are we getting the beta of 1.20? Yep. So 1.202. That's the beta we are getting. Yeah. So first portion is done. We have done with the beta. Now after that, I need to obtain the regression equation. I need to obtain the regression equation. So regression equation, we know it is of the typical form. So regression equation. Right. Okay. Yeah. So we are aware that regression equation is of the form y equal to mx plus c. This is the normal form of regression equation, but we can actually modify this and say that return of security A, because the name of our security is A over here, return of security A will be equal to beta into x. Now instead of x we have the market, plus instead of c we call it as alpha. Now to form the equation we have already got the value of beta, which is 1.202. Now we need the value of alpha. Now how do we obtain the value of alpha? So this alpha, this alpha can be computed as A bar, okay, minus beta into M bar, or average return of A minus beta into average return of market. So let us try to get the value of alpha. So therefore, alpha is equal to, how much is A? Average return of A is 5.75. Okay. Then this is minus 1.202, right? Multiplied by average of market return, which is 5.75. Okay. So what is the alpha value? What's the value of alpha we'll be getting? It will be 5.75 minus beta multiplied by 5.75. One second. This was average return of A. The average return of A was 6.33. Right? So 6.33 minus beta into average return of market. So that's like minus 5.77, or I can say that this is minus 0.58. So minus 0.58. That's the value of alpha. So finally, we get the regression equation, or the characteristic market line. So characteristic market line is not capital market line, CML. This is our characteristic market line. So characteristic market line is given by return of A is equal to beta into market plus alpha, which is, henceforth specified to be return of A will be equal to beta of 1.202 into market value minus 0.58. So this is the characteristic market line, guys. This is what we mean by the characteristic market line. Okay, return of A is equal to 1.202 return of market minus 0.58. This is a characteristic market line, or this is what we mean by the regression line, guys. This is what we really meant by regression line, or the line which is said to be the characteristic market line. So this line is actually representing the line which we were talking of earlier, right? When we were talking of earlier, right? This particular line is the straight line which passes through the scatter plot of this. Now let me just show it to you how this really works out to be, the scatter plot. So let me just take down the values over here. Now return of A, these returns, the returns that we have, values of A, okay, these returns are our actual returns. These are our actual values of A. But we already have an equation over here for us, which is A is equal to 1.202 into market minus 0.58. This equation, I can use it for calculating the regressed A. Now, regressed value of A will be equal to 1.202 market return minus 0.58. So, regressed return is 1.202 market return minus 0.58. This is the regressed return. So I can calculate the regressed return as 1.202 multiplied by, market return 1.202 multiplied by the market return, which is 8 minus 0.58. I'm just trying to calculate the regressed return of A by using this equation. So how much would this be equal to? How much would this be equal to regressed A? It will be 9.036. Okay, so regressed A is 9.036. Same way, I can get the regressed values of A for all the respective market returns. Okay, so originally we had this market return and the actual return of A. Then the regressed return was computed as 1.202 M, which is 1.202 market return, minus 0.58. So minus 0.58 was used, and this 1.202 beta was used to obtain the regressed return. Now, what do you mean regressed? It means the estimated or forecasted return. So actual return was 12, but using market as the independent variable, we tried to calculate the regressed return. Now, let me just show you one thing. If I just plot all the three things together, one is the market return, second is the actual return, and third is the regressed or estimated or forecasted actual return, forecasted returns. So when market was 8, the actual return of A was 12, but the regressed or the forecasted return will be 9.036. So let me just insert a scatter plot. And now possibly, you will be able to recognize that we have actually formed a line. Can you see a line being formed, guys? Can you observe the line being formed? Look at the orange line. Look at the orange dots. Do they appear to be in the straight line? Look at the orange dots, guys. Are they looking like they are in a straight line? Yep. You can just see that all the orange lines that we have are forming a straight line, guys. Right? And that is what our objective was when we were looking for calculating the regression. Our objective was to form a straight line like this. And this is what we are actually getting by the form of this regression. Okay, so one was a series of actual return, and the other is a series of regressed or the estimated returns. The regressed or the estimated returns. So these regressed or estimated returns were helpful for forming a straight line going through the middle of our scatter diagram. Now, obviously, we have a very small set of data points. When we have a larger data point, you will be able to see that the points are scattered around this line, and then we have a all straight line piercing through the entire scatter plot. Okay, so this is the characteristic market line, and what role is the characteristic market line playing? It gives us a trend of the security return with respect to the market return, right? And it's a straight line that we observe. Okay, are we good till now, everyone? Because we are done with characteristic line, but the most important part is yet to come. Are we clear? How do we calculate the characteristic market line? Yes. So the idea is first you need to get the average returns of market, average return of the security. Then you compute in the second step, compute the beta, which is by using the covariance upon variance formula. Then, since the equation also requires a calculation of a constant term, which is the alpha, constant of which is alpha, we compute the alpha as average return of A minus beta into average return of the market. Okay, so we have the alpha number. Alpha is minus 0.58. Right, so we simply substitute the values. We got the value of alpha. That alpha and beta, when we substitute it over here, we get this particular line. So we said that return of A will be 1.202 times of market. Add to it the alpha value, which is a constant term. And that actually gives us a straight line like this for us. Okay. I hope the process is clear, because the most important part, is going to come up in the next upcoming session. So next, almost 45 minutes to 60 minutes is going to be really crucial for us, because we'll be discussing something really different, and we'll be deriving some formula also. It's going to be really interesting and mathematical. Those who love mathematics, they'll love the upcoming 1 hour of their life. Okay, so I hope, but before that, I want everyone to be very clear about how this regression line was formed, and what do we mean by these regressed lines or these regressed values. Are we all clear with this part? The regressed values and the regression equation. Yes? We're all good, everyone? Shall we proceed? I need a confirmation from you, because otherwise the next part, is something going to be, out of the way. You'll be like, what are you speaking, sir? Because before that, we need to know, are we very clear how to compute the regression equation or the market line, characteristic market line, and of course the regressed values also. Okay, we're all clear? Perfect. Now let's go for the next aspect of sharp single index model, where sharp single index model takes the sharp's beta model a step ahead. Beta, or you can say the CAPM model, capital asset pricing model, it stated that the securities will actually be able to give you a risk premium for only the systematic risk, because unsystematic risk you can do away with, you can simply do away with the unsystematic risk by simply taking a proper diversification of your portfolio. So when you can definitely undertake that, proper diversity, with the help of diversification, when you can do away with the unsystematic risk, you will be only compensated for the systematic risk. But that model was actually not able to tell me how much is my total risk, how much is my systematic, and how much is my unsystematic. Now, this particular model of Sharps, which is a single index model, that is now helpful to break the total risk into systematic and unsystematic portion. How is that really done? How is that really done? Let's try to understand it with again this same data. I'm going to use this same data for further analysis. Okay, so these are like the regressed values that we have. Now, in this particular data point, we have something called as the actual values. We have something called as the actual values of the security and the regressed values of the security. Are the actual values and regressed values equal to each other? Are the actual values and regressed values equal to each other? No. There is some sort of difference. There is a difference, right, between the regressed values and the actual values. And you will obviously find that there is some sort of difference that we have between the actual and the estimated value. Because you might be estimating something, right? But the actual may not be exactly equal to your estimation. It may be in and around your estimation, right? So be whatever be level of your astrology or astronomy, you cannot forecast. Absolutely, you cannot forecast with 100% accuracy. There will be some sort of error or inaccuracy creeping into your data. So if I look at the error term over here, the error term, which is also going to be called as, let's say, EI. Do we see any sort of error in our estimation? Yes, sir. Actual value was 12, but you know what? We regressed and we found the value to be 9.036. Actual value was 12. We found the regressed value to be 9.036. So obviously there is an error. Actual is 12 and this is 9.036. So we found that error is of 2.965. This is the error that we have in our estimation. Okay. Same way, we can definitely say that there is error in each of our estimations. Now, does that mean our model is totally flawed? No, you cannot say that. Because we are not in a position, in fact, no one in this world, no one in this universe is rather in a position, apart from God himself, to forecast the future with 100% accuracy. There will be some error and we have to live with that. There will be definitely some error and we have to live with that particular aspect. Now, there is this error term coming in, but you know what? If you just take a total of all the error terms, it's almost going to be like, 0. Now we can see that the error term is going to be 0 because the forecasting is obviously having some error. But when you take the total of all the errors, you know what? It's always going to be 0 because sometimes you will be under forecasting, sometimes you will be over forecasting. But the net effect of all is that in a period of time, your net error is going to be 0. So this error term is what we got as the difference between the actual and the regression, right? So can I say one thing over here that our actual return is actually the regressed return plus the error term. Am I right? The actual return is the regressed return and the plus the error term, or I can say like this also, that error in our estimation is actual minus regressed. Error term is basically actual minus regressed. So I can simply rearrange and say that actual is nothing but the actual returns is nothing but regressed plus the error term, right? So we can actually call it as actual return of A is going to be the regressed part. Regressed part is 1.202 return of market minus 0.58. So this particular portion is the regressed portion. And can I say, sir, since I need to add the error term, let me call it as plus EI plus the error term. So actual rate of return, the real rate of return that you observe in the market is going to be the regressed return, which is this portion, 1.202 return of market minus 0.58 plus EI, or I can say simply A is 1.202 market return minus 0.58 plus EI. This is the real characteristic market line is. Because now we are targeting the actual return. Sir, what was the earlier line then? This earlier line was regressed value of A. But we want to know how do we model the actual rate of return. So the actual rate of return is 1.202 times of market minus 0.58 plus error term. Are we able to understand this? Are you able to understand this, everyone? How are we modeling this particular actual return of A? So actual return of A is 1.202 times of return of market minus 0.58 plus error term. Okay, this is the representative of the characteristic market line. This is our characteristic complete, we can say this is our complete characteristic market line. Okay, that's our characteristic market line. Now, how do we really go about, calculating the systematic and unsystematic risk? How do we go about, calculating the systematic and unsystematic risk? Okay. Now, for that, we need to understand what is a total risk and what is a systematic risk. Okay. See, total risk, understand, total risk is the variance of A. The way your actual return of A, the way the actual return of A is, changing, the variance or the standard deviation that we have, standard deviation square of A, is actually the total risk of the security. This is the total risk of the security. The variance of A is the total risk of the security. Okay. Then, what is the systematic risk? Systematic risk is, variance of regressed A. So, as I stated, actual is equal to regressed plus error. Actual is equal to, regressed plus error. So, we say whatever is the variance in actual return of A. So, variance of actual A is the total risk, whereas systematic risk is represented by variance of the regress, this portion, variance of this regressed. And what is the unsystematic risk? Unsystematic risk. Unsystematic risk is given by variance of error. So it is simple, like your actual return was 12. Okay. The model of single index or sharp single index model was able to give you a regressed return of 9.036. The model of A or sharp single index model was able to give you a regressed return of 9.036. So what was left out? It is 2.964. So out of these movements of actual return, this much portion, the regress portion, was actually captured by the model. So every time you have the actual return and every time you have the regressed return. So the movement that is happening in the actual return, to some extent was captured by this model. And there was some portion which was not captured by this model. So the movements or the variance which was defined, which was captured by this model, is going to be the systematic risk, because this return is dependent on the market return. So whatever return you were able to link, whatever portion of your return you were able to link with the market return, that is the systematic portion. And whatever thing which you were not able to link, that's your unsystematic risk or the error term. Okay, so total risk is basically variance of actual A. Systematic risk is the variance of the regressed returns. And unsystematic risk is the variance of the error term. Okay, there's a variance of the error term. So can I say over here, going by this simple fundamental, we can say that total risk is equal to systematic risk plus unsystematic risk. Right, guys? Can we call the total risk to be equal to systematic risk and unsystematic risk? Right? Correct? So total risk is equal to systematic risk and unsystematic risk. I think the screen sharing just left. Give me a moment, guys. Yeah. So total risk is systematic risk plus the unsystematic risk. So can I say variance of actual A should be equal to variance of regressed A plus variance of error term. Right? So this particular equation is definitely going to be satisfied whenever we are talking of systematic and unsystematic portion. Okay, so variance of actual A will be equal to variance of regressed A plus variance of the error term. Now, just to match, just to give you that there is a matching concept over here. We are not calculating the values of regression. We're not calculating the values of variance of A and regression variance of this and variance of this. And just using the Excel tool just to make you understand, just for the easy calculation purpose. This is not expected from you in the exam. Okay. So, like if I ask you what is the total risk? Total risk, as we said, it is variance of A. Right. So variance of A, I can calculate it as simply using the Excel formula. Variance of A or variance of actual returns of A. I'm just using this. You can try it at home later to calculate the variance values. It should be equal to 82.89 for the total risk of the market. Then when we have systematic risk, we can calculate it as variance of regressed returns of A. This works out to be 58.00. And unsystematic risk is simply variance of the error term, that is 24.90 or 89. So moreover, you can see that when you calculate the variance of this actual returns, that works out to be 82.89. Variance of the regression term or regressed values of A, that is 58. And unsystematic risk variance is basically 24.90. And you can definitely see that the total of these two is definitely matching with 82.89 because there may be some minor rounding up error, but that's okay. That we can understand. We're getting the total of these two. If you take a total of these two, that is 82.9, which is exactly almost same as this. Okay. Minor difference due to the rounding up, nothing there. So we found that variance of A will be equal to variance of the regress term plus variance of the error term. Okay, so that is very much true that total risk will be equal to systematic risk plus unsystematic risk. Now, Sharp actually gave us a bit different way of calculating this systematic. Now, Sharp doesn't require you to, calculate the variance of all the three terms. Sharp doesn't require you to calculate the variance of all the three terms. What it says is it just takes ahead this particular equation and gives you an identification of what is systematic and what is unsystematic. Okay. Now, we have this regression line that return of A is equal to beta into return of market plus alpha. Okay. And plus the error term. Now, the variance of error is 0. No, variance is not 0. Now, the total of error term is 0. there is definitely a variance. You say that variance is 0 if all the values are equal. The values are not equal. The values are changing over here, right? So there will be, of course, variance. The total of error is going to be 0. That is what you mean. Got it, Mamta?
Sir, please explain again.
Here, the error term total is equal to 0. That doesn't mean variance is equal to 0. How do you compute the variance? How do you compute the variance? Variance is like variance of x. That is summation of x minus x bar the whole square upon n. So if you want to calculate the variance of error term, you will have to take error term minus expected return, which is 0, but it will has to be whole square.
Okay, sir, got it.
Got it? So variance of error term is not 0. The expected return of or the mean is 0 for the error term. Okay, but there is definitely a variance. Now, coming to this model, guys, security return A is beta into the market return plus alpha plus error term. Now, Sharp says, do one thing, apply variance throughout. Apply variance throughout. So Sharp says, instead of A, take variance of A is equal to take variance of beta into market, take variance of alpha, take variance of error term. Now it further expands and says, now this beta value, is it a single constant number or is beta changing throughout the question? In this question, was beta a single constant number or was it changing? It's a constant number, right? It's a constant 1.202. So whenever there is a constant and you have a variance, the rule is, whenever you have a constant, you just take outside the bracket. But since this is a variance, I cannot take directly beta outside because it will be actually beta squared. So beta squared into variance of market. So when you apply variance to beta into market, since variance is obviously, x minus x bar the whole square. So beta will be actually getting square and outside we will have beta square plus variance of alpha. Was alpha a constant term or was it a varying term? The alpha over here, minus 0.58. What is it? It's a constant term, right? So what do you expect about the variance of alpha? What do you think about variance of alpha? Will it change?
Alpha square.
No, it won't be alpha square. Variance of alpha will be 0. Here, beta square was happening because beta was with m. Because beta was with m and therefore beta was taken outside. Like if you want the variance of beta, you will compute it like this. Summation of beta into market, minus average of beta into market upon n with the square. So here we had like, beta square, average beta and square. So you got that beta square outside. But when you have a alpha, which is a single constant term without any varying term, there is no change in alpha. The alpha is just a constant term, right? So this particular alpha minus 0.58, it's just a constant term. And therefore, since there is no variance in the alpha, the variance value is going to be 0. Plus variance of error term. Variance of error term will be simply kept as it is, variance of error term. Now we can actually redefine this as standard deviation of A square. Now standard deviation of A square means the variance of the security return is defined as beta square into variance of market plus variance of the error term. This is the model given by Sharp single index to break our total risk into systematic and unsystematic. This is the measure of total risk. This particular portion, which is beta square into variance of market, this is a measure of systematic risk, and this portion is going to be indicated as unsystematic risk. Okay, so we have the total risk getting distributed into two portions, the systematic risk and the unsystematic risk. That is what we have done over here also by calculating the variance of A, variance of regressed A, and variance of the error term. Now, suppose if we have only this data available for us, like we have only this data, right? I can calculate the systematic portion and unsystematic portion by looking at this equation itself. By looking at just this equation, I can calculate what is systematic risk and what is unsystematic risk. Okay, so like to compute the total risk, I need the variance of A. Now to compute the variance of A, we take A square, and of course we know the beta value, and we also know the now to compute the variance of market, we need to take the market return square. So this is like A square, and let us calculate the market returns also. Okay, so these numbers are kept over here. Okay, now we need to compute the value of variance of market and variance of the A, because I have to apply this particular formula, right? I have to apply this formula. So to compute the total risk, I need the variance of A. Now to compute the variance of A, I can compute it simply by taking summation of A square upon n minus A bar square. This is nothing but the same standard deviation formula, but without square root sign. Same way, I want to compute the variance of market. So variance of market will be also computed on the same lines, which will be summation of m square upon n minus m bar square, right? So let's take this particular summation because we have already solved this, right? We've got the summation, and I think we've got the averages also earlier. Okay, so average M is 34.5 divided by 6, which we have already got, and the average A is 38 divided by 6, which was 6.33. Now, variance of A can be computed as summation of A square, which is 738 divided by 6 minus variance of A, average return of A square. So this is what we got, the variance of A. Then variance of market will be summation of M square divided by 6 minus average market return square. So the variance portion, variance of market is 40.15. Okay, so we got the variance of A, variance of market. So now we are ready to implement this sharp single index model, which is total risk is this 82.89. Now to compute the systematic risk, what do we need? We need the beta square into variance of market. Do we know the value of beta? We have computed the value of beta in the previous case, right? Which was, I think 1.202. 1.202. Beta is what we have computed, right? Because based on that, we have created the regression equation. So beta is 1.202. Now let's break this systematic and unsystematic risk. So we say that total risk is basically variance of A, which is 82.89. What do we mean by the systematic risk? Systematic risk is computed as, beta square multiplied with variance of market. So this is beta square. Now beta square, when we say it is 1.202 square, right? And you multiply it with variance of market, which is 40.15. So we get the systematic risk to be 1.202 square into variance of the market, which is 58, right? And then the balancing part will be the unsystematic risk. The balancing part will be the unsystematic risk, which is total risk minus the systematic risk. So the difference will be regarded as the unsystematic risk. And if you can just recall, these are the same numbers that we got, 82.89, 58 and 24.89 over here also. So a totally, different and a radical way to evaluate the risk of a particular security is to look at its total risk, identify what portion of the total risk is, systematic, and of course the balancing part, the balancing thing will be the unsystematic risk, right? So what do we need to remember? We need to remember this particular formula. Variance of A is equal to beta square into variance of market plus variance of the error term. Okay, so that's the distinction between the systematic and the unsystematic risk that we were able to make when we were looking for this Sharpe's single index model. Is it clear, everyone? How do we break the systematic and unsystematic risk from the total risk? And also, how do we form a regression line? Correct, guys? Perfect. So that is about this particular Sharpe single index model. Now, let us do, maybe one more question just for our practice to, obtain the beta, then characteristic market line, and to also look for the systematic and unsystematic portion. So for that, let us take this question number 12, guys, just for the sake of, getting a better practice. So we have market and the security return. So market return and the security returns. Market returns are 20, 22, then we have 25, 21, 18, minus 5, 17, 19, minus 7, and 20. So 20, 22, 25, 21, 18, minus 5, 17, 19, minus 7, and 20. Security returns are 22, 20, 18, 16, 20, 8, minus 6, 5, 6, and 11. Okay, so these are the market return and the security return. We will compute from this the beta values. Also, will form the regression equation out of it, and we will also be breaking the total and systematic total risk to systematic and unsystematic portion. Okay, now, so first what we need is the summation. So let's take a sum of the market returns and the sum of security returns. Now calculate the average M average market return. So average market return is like 150 divided by 10. We have 10, right? Yeah. And also let us compute average security return, which will be 120 divided by 10. So, okay, first one is security and other is market. Okay, so this is security and this is market. So average security return is 15 and average market return is 12. Okay, now to form the regression line, what we need is certain columns. So we need to have the columns of SM, M square, and we'll also have the column of S square because we need the variance of security also, and of course variance of market. So S into M, I'll just give you the values of total of these terms, and I will require your help to calculate the value of beta. Okay, so security square and market square, these are very much procedural part, and I think we'll be able to do that. Okay, so these numbers are there. Now what I need from you is variance of S. I need from you variance of security. Okay, then I'll need from you variance of the market, and of course I'll need beta from you. So beta, I'll just write down the formula over here and you just give me these numbers. Yeah, variance of security is computed as summation of S square, or sorry, not summation directly. Yeah, N summation S square minus summation X. Summation S minus summation S the whole square, the whole divided by N summation, one second, what am I doing this? Yeah, variance of S is summation S square upon number of terms minus S bar the whole square. So you can give the security variance from this. Variance of market will be summation M square minus M bar square, right? Summation M square upon M minus M bar square. Beta will be computed as N summation SM minus summation S into summation M, the whole divided by N summation M square minus summation M the whole square. Okay, give me these numbers, guys. Give me these numbers, which is the security variance, the market variance, and of course the value of beta. I'll wait for some time. Please give me these numbers, guys. I want you to get involved in the calculation. I've given you the totals of security, totals of market return, total of security square, and total of market square is already given to you. I want you to obtain the security variance and the variance of the market. Yep. Give me these numbers, guys. How much is the security variance? What is the variance of security? Okay, 114.8. Okay, So security square divided by 10 minus average of security square. 114.8. Perfect. Same way, give me the variance of market and beta, guys. Yeah, variance of market. This is this divided by 10 minus average square. So that's 70.6, right? What about the beta? The beta value. Value of beta. What is the value of beta? Compute the value of beta, guys. Beta is n summation Sm. So which is 10 into summation Sm minus summation S into summation M divided by n summation M square minus summation M the whole square. This is 7060. Yeah, so beta value is 3570 divided by 7060, which is 0.505. Or we can say beta is 5057. So beta is 5057, guys. Right? Okay, so we got the variance of security, variance of market, and now we've got the beta. To now form the characteristic market line, we need alpha. Because characteristic market line is given as beta into market return plus the alpha plus the error term, right? So what is alpha? Remember the formula for alpha? Alpha was computed as what? A bar minus beta into M bar. So over here it will be S bar minus beta into M bar. So that will be S bar. S bar is basically 15 minus beta into 15 minus beta is 0.5057 multiplied by M bar. M bar is 12. So alpha is 15 minus 0.5057 into 12, which is 8.93. So we got the alpha value as 8.93. So characteristic market line will be 0.5057 multiplied by market return plus alpha of 8.93 plus error return. So I can say this represents the security return, or I can say the security return is defined as this particular equation. Right, so security return is defined as this particular equation, guys. 0.5057 into market return plus 8.93 plus the error term. Yes. Oh, that's the first part we have done. We have done beta, we have done with the characteristic market line. Now the next part is to break the risk into systematic and unsystematic, which is very simple. We'll take help of this particular data. What is the total risk? Total risk of security. What is the total risk of the security? Can I say it will be variance of the security? Now variance of security is 114.8. Variance of security is 114.8. What is the systematic risk? Systematic risk. Systematic risk is simply variance of, or we can systematic risk is defined as beta square into variance of the market. So beta square into variance of market means beta is anyways 0.5057 square multiplied by variance of market is 70.6. So we can say the systematic risk will work out to be 0.5057 square multiplied by the variance of market, which is 18.05. Right? That's a systematic risk, 0.5057 square into variance of market. Then what will be the unsystematic risk? How do we get the unsystematic risk? That is simple. Total risk minus the systematic risk, which is just the difference between these two. That's the unsystematic risk number. So total variance, variance of the regress returns, and the variance of the error term, which is the unsystematic risk. Okay. So unsystematic risk is defined over here, 96.75. Total risk was 114.80. And the difference, of course, systematic and unsystematic got this got bifurcated. Okay. Are we clear? How do we obtain the systematic portion and the unsystematic portion from a particular given data set? Yes, everyone? Okay. Chalo, great. So that completes our sharp single index model conceptually, and also we've done a couple of questions on that. Now we will have to look at the other implications of this, right? So let me do some derivation for you with regards to the other implication, and then we will try to come up with we'll do a particular question on that. Okay, let me just do a bit of between the Markowitz portfolio risk and the portfolio risk of the Sharpe. Okay, now let's say we have portfolio risk. There are two approaches to it. Okay, the first is Markowitz, what we have learned already, right? And now we are looking at Sharpe's. So Sharpe's portfolio risk is defined like this. Sharpe's portfolio risk, which is nothing but variance of the portfolio. Can I say Sharpe said that the total risk will be equal to systematic and unsystematic. Now, the same concept we can apply even for the portfolio risk. So this should be like when Sharpe stated this particular part that the Sharpe has stated this one. Yeah, total risk the total risk of A was equal to beta square into variance of market plus variance of error term. Same way over here, we can have it as, Sharpe's portfolio risk to be beta of portfolio square into variance of market plus variance of error of portfolio. What was applicable for a single security, that will be applicable even for two security portfolio, right? So we can say when your variance of a single security was equal to beta of that security square into variance of market plus variance of error term of that security, right? So same that is applicable for the, we can say that same is applicable for the portfolio also. So let us just try to expand this. Suppose there are two what do you say, securities in our portfolio. So what will be the beta of portfolio? Well, understand that portfolio beta is given as weight of x into beta of x plus weight of y into beta of y. That's the beauty of portfolio, or that's the beauty of the portfolio beta. You can simply calculate it as weighted average, not like Markowitz portfolio where you need covariance, correlation and all. That is not required. You can simply take the beta of portfolio as weight of x square into beta of x plus weight of y into beta of y. So I can just substitute it over here and say that beta of portfolio square will be actually weight of x into beta of x plus weight of y into beta of y square into variance of market, right? Plus now variance of error of portfolio. Here I'm going to apply the Markowitz formula. Okay, here let me apply the Markowitz formula. So Markowitz formula will be stated over here as simply weight of x square into variance of error of x plus weight of y square into variance of error of y plus 2 into weight of x, weight of y, variance of error of x, variance of error of y into correlation between error of x and error of y. So this is what we obtained as variance of the error term of the portfolio. Now, one peculiar characteristic of this is, what do you think what should be the value of this correlation? What do you think what should be the value of correlation between error of x and error of y? What do you think? What do you think? Will there be any correlation between two error terms? Something which we are not able to track, the reason why something, the return was there. Do you think there will be any correlation between two error terms, error of x and error of y? Can there be a correlation between two error terms anytime?
Portfolio, the both errors will negate each other. So
No. When I'm talking of the error term, the balance, the residual that we calculated, like in this case, we computed the error term. So this is error of one of the securities. Same way you can calculate error in the forecast of the other securities. So do you think that there will be any sort of correlation between error of one security and error of other security? Will there be any correlation? Of course, no. Ideally, there shouldn't be any correlation between both of them because they're totally unrelated items, right? They're not related to each other. Error in the forecasting of one value and error in the forecasting of other value, they cannot be ideally be related, and therefore this correlation is considered to be 0. So if we have that correlation as 0, I can say that my formula for Sharpe's portfolio risk will be simply weight of x into beta of x plus weight of y into beta of y, the whole square into variance of market, plus it will be just weight of x square into variance of error of x plus weight of y square into variance of error of y. This is the formula which has been given by Sharpe to compute variance of portfolio. right? So what was given in the Markowitz, it was the totally different thing, right? So this is the Sharpe's portfolio risk. Sharpe's portfolio risk formula. And if I contrast it with what has been given by Markowitz, that is actually weight of x square into variance of x plus weight of y square into variance of y plus 2 into weight of x, weight of y, standard deviation of x, standard deviation of y, and a correlation between x and y. Okay, this was something that was given by Markowitz. So Markowitz portfolio risk is what we have already learned. We are just trying to contrast it with the Sharpe's portfolio risk. Now, out of these two, which one is easy to compute? Sharpe is easier to compute. And the calculation part, the numbers that we need, that is also lesser in case of Sharpe, because in Sharpe you need beta and you need the variance of error terms. Whereas in Markowitz portfolio, if you have two securities, you need to compute correlation. If you have multiple securities, you need to get so many different number of correlation between A and B, between B and C, between A and C. So as the number of securities increases, Markowitz portfolio formula becomes a bit difficult to implement. But Sharpe is an advanced form where just single line item calculating the portfolio beta and getting the portfolio risk is quite intuitive, and it's easier for us to solve also. Okay, so we need to remember this Sharpe's portfolio risk. What are the inputs that we need in Sharpe's portfolio risk? Weightage of both the securities, beta of both the securities, and unsystematic risk or variance of x and y. These three items we need: beta of both securities, weightage of both securities, and unsystematic risk between unsystematic risk of both the securities, along with, of course, the variance of market. Okay, so this is what the Sharpe portfolio risk is. Now, let me just solve a question which will be targeting this particular formula. Okay, question 33, guys. Let's try to solve this question 33. Okay. So we have like three shares given to us, A, B, C. Portfolio weights are given. We have like securities A, B, C. Weightages are given as 0.2, 0.5, one second, yes. Yeah. So question 23, we have securities A, B, and C. And there we have like weights given to us as 0.2, 0.5, 0.3, 5, and 0.3. Then we have the beta values of 0.4, 0.5, 1.1. Okay, expected returns 14, 15, 21. And then we have total variance given to us. total variance is given to us 0.015, 0.025, and 0.100. Okay. Now standard deviation of market portfolio is given. So standard deviation of the market portfolio is 0.1 because that's 10%. And the other data that we have is regarding covariance. So we have the covariance between A and B. Covariance between A and B is given as 0.030. Then we have covariance between A and C. 0.02. And covariance between B and C. 0.04. Okay, so you are given the following information for covariance. Now the first part is to compute the portfolio beta. Portfolio beta. How do we go about computing the portfolio beta? Portfolio beta can be simply computed as just writing down the securities, their weightages, and the beta values. And what we need to do is we have the weights, betas. What we need to do is we need to just obtain the weights into beta values. So weights multiplied by beta, and then we take a sum of it. So portfolio beta is 0.66. Portfolio beta is 0.66. Okay. Then we have residual variance of each of the three shares. Now residual variance means the unsystematic risk. Unsystematic risk for each of those stocks. Okay. So let me name them as A, B, and C. We know the total risk. Total risk is given in the question, guys. Total risk of A is 0.015. And same way for B, we have 0.025, and for C it is 0.1. Okay, that's the total variance. Now we need to get the unsystematic risk. Now to get the unsystematic risk, I just need to subtract the systematic risk. Now systematic risk can be computed as beta square into variance of market, right? So beta square will be beta of A square into variance of market will be standard deviation square, right? So systematic risk is simply the beta square into variance of market. Variance of market is simply standard deviation square. Same goes for B. So for B, it is going to be beta of B square into variance of market, then beta of C square into, again, the variance of market. Okay. And then finally, the unsystematic portion. Unsystematic portion will be total risk minus the systematic risk. Total risk minus the unsystematic risk, minus the systematic risk, that will give you the unsystematic risk portion, or this is what we mean by the residual variance. So residual variance is simply the unsystematic risk portion, the total minus the systematic risk. Okay. Then portfolio variance using Sharp index model. Now portfolio variance using Sharp index model is, what we have already covered. Yeah. So portfolio risk using Sharpe single index model, Sharpe's portfolio risk. For that, we need to get the portfolio beta, square it, then variance of market, and then this particular portion. So for Sharpe single index model portfolio risk, we need to get the weighted beta. Weighted beta is already there with us, right? So weighted beta is already there with us, 0.66. So weighted beta square, that we can do it easily. Variance of market also we can calculate. We need to compute this portion, which is weight of x square into error of x square plus weight of y square into variance of error of y. So let's try to compute that. So what we need over here is, since there are 3 securities, we need to get the unsystematic risk of portfolio. Unsystematic risk of portfolio. Unsystematic risk of portfolio will be like weight of x square into variance of error of x plus weight of, okay, so we have A, B, C. So weight of A square into variance of error of A plus weight of B square into variance of error of B plus weight of C square into variance of error of C. Okay, so this will be equal to weight of A square into variance of error of A. Weight of A square will be, weight is 0.2. So it will be like 0.2 square into variance of error of A. Now variance of error of A, which is the unsystematic portion, is what we have got already over here. This one, variance of or unsystematic risk is this. So 0.0134 plus weight of B square. Weight of B square is, weightage is 0.5. So that will be 0.5 square into variance of error of B. Now variance of error of B is 0.0225 plus weight of C. Weight of C is 0.3. 0.3 square into variance of error of C. The variance of error of C is this 0.0875. 0879. So this portion, which is the unsystematic risk, is 0.01407. Okay. Please calculate again the systematic risk. Systematic risk is like this: beta square into variance of market. So beta square is 0.4 square into 0.1 into 0.1. Did you do it this way, Ginny?
Yes, sir. Now got it. My error.
Noted. Okay.
Thank you, sir.
Yeah. Fine. Okay. So we got the unsystematic risk as this portion 0.01407. Now what will be the systematic risk of portfolio? Systematic risk of portfolio will be beta of portfolio square into variance of market. So this will be beta of portfolio square, so which is 0.66 into 0.66 into variance of market. So that's 0.00436. That's the systematic risk. Now, of course, the total risk, because the question asks us to compute the portfolio variance or total risk, or which is also said to be portfolio variance. Portfolio variance will be unsystematic risk plus the systematic risk. So which is 0.0147 plus 0.00436. So this is simply the total risk that we are talking of, total risk of the portfolio variance. Total risk of the portfolio variance will be simply summation of unsystematic and the systematic portion. Now this is, of course, as per sharp single index model. So as per sharp single index model, we get the total risk as 0.01843. Okay. Now, total risk as per Markowitz model. How do we get the total risk or variance as per Markowitz? Variance as per Markowitz model. Variance as per Markowitz model is computed as weight of A square, into variance of A plus weight of B square into variance of B plus weight of C square into variance of C plus 2 into weight of A into weight of B into covariance between A and B. But since we have 3 securities, I need to consider the other covariances also. So plus 2 into weight of B into weight of C into covariance between B and C plus 2 into weight of A into weight of C into covariance between A and C. Okay, so I need to compute the Markowitz model in this particular form. So I can apply it here as weight of A square. Weight of A square is 0.2 square into variance of A. Variance of A is this 0.015 plus weight of B, which is 0.5 square into variance of B, which is 0.025 plus weight of C, which is 0.3 square into variance of C, which is 0.1 plus 2 into weight of A, which is 0.2 into 2 into 0.2 into 0.5, which is weightage of B, into covariance between A and B. Now, covariance is basically given as 0.03 plus 2 into 0.5 into 0.3. So we did the covariance between A and B. Now we're going to take the covariance between B and C. So B and C, it is 0.04 plus 2 into 0.2, which is weightage of A, weightage of C into covariance between A and C. So this is the same term. I just need to place an equal to, and we get this as 0.3625. So of course, there is a difference in the portfolio risk calculation because of the statistical reasons. But yes, there are 2 different methods to compute the portfolio risk. Okay, so with that, we are through with the comparative thing about Markowitz and the total risk of the portfolio using Markowitz as well as the Sharpe model. Now, let's take a break. Okay, let's take a break, guys, of 10 minutes. And then after that, we'll go ahead with the next set of models. Okay, yeah, before that. Yeah, Ginny?
सर, तो फिर
हम्म।
ये जो मार्कोविट्ज मॉडल और शार्प मॉडल है, तो फिर हमें रियल लाइफ में इन दोनों में से किसको प्रेफर करना चाहिए?
Real life में there are even more advanced model, right? So the advantage of sharp is you're able to distinguish between systematic and unsystematic. So you can ideally see that what unsystematic risk am I facing, what systematic risk am I facing. So आपको अगर portfolio optimize करना है, तो what will you try? You will try to minimize the unsystematic risk. So it's like a measure of portfolio performance also. How much you have been able to reduce the unsystematic risk,
यस सर, क्लियर, थैंक यू सर।
right? So the motive is different. Okay, let's take a break, guys. We'll meet up after 10 minutes for the discussion about the next set of models. Let's go for the next model for calculating the required rate of return from an investor, which is arbitrage pricing theory. So the next model is about arbitrage pricing theory. Okay, arbitrage pricing theory. So this APT model, the arbitrage pricing theory, it takes the KPM model one step ahead. It says that we calculate the required return on a particular security as risk-free plus beta into RM minus RF. So this is like, it says that the required return is simply risk-free plus beta multiplied by the market risk premium. Right, market risk premium. This was the statement of KPM. Now, arbitrage pricing theory takes it further and it says that you know what, the market risk premium, which is computed as RM minus RF, that is not actually the source of risk. KPM says that RM is the source of risk, or RM is the market return as the market moves in comparison to that. However, security moves, that is what is represented by beta. But the idea is, in reality, does the market move? Does the market rate of returns move on their own? Are the market rate of returns moving on their own, or are they caused by something? Like you see the movement in Nifty, movement in Sensex. Are they moving by themselves? Is the variation in the values of the market returns happening on their own, or are they caused by some factors?
Demand and supply.
They are caused by some factors, right? So the market return movements, the RM movements, are caused due to some sort of movement due to some other variable. Like we say that Nifty has increased by some points, or Sensex has increased or decreased by certain points. What is the reason that Nifty or Sensex is changing? Because there has been some other factors which are bringing the change in the market. Now, what could be those factors? Those are like macroeconomic factors, right? So, for example, you see that Government of India publishes GDP figures, and those GDP figures are, good numbers. So, what do you expect the Nifty and Sensex to happen? Will the Nifty and Sensex returns increase or decrease? Will the Nifty and Sensex returns increase or decrease? The Nifty and Sensex values, the overall market, when the GDP growth rates are forecasted to be higher.
Increase.
So there will be obviously an optimism in the market, and you'll see that the Sensex and Nifty zooms up. Same way, if there are inflation numbers which are very high, so what do you expect the returns of? What do you expect the Nifty and Sensex values to be happening? Of course, Nifty and Sensex values will be going down because of the inflation number. Because as the inflation rises, it will impact the industries. Foreign exchange reserves, inflation numbers, RBI repo rate, energy consumption. So there are many different macroeconomic factors which are playing a role in determining the return that an investor is going to get due to the market, of course. Now, so arbitrage pricing theory takes it a bit ahead, and it says that instead of looking at market as one whole reason for the return of the security, it's better to break down what causes the market to move, right? So it could be multiple factors. It could be your GDP growth rate, it could be your inflation numbers, it could be your foreign exchange rate, it could be your forex reserves, it could be your unemployment data, it could be RBI action, it could be changes in the government, right? So there are many different such parameters which are going to put a decisive role regarding the rate of return for the investor. Okay, so that is where the arbitrage pricing theory comes in, and it expands this particular model into multiple parts. So as per arbitrage pricing theory, required return of an investor will be lambda 0 plus beta 1 into lambda 1 plus beta 2 into lambda 2 plus beta 3 into lambda 3 plus beta 4 into lambda 4. In this way, you can just list down as many factors as you can. Now, what is lambda 0? Lambda 0 is nothing but risk-free rate of return. Okay. What are beta 1, beta 2, beta 3? All these are called as factor betas. And then we have like lambda 1, lambda 2, lambda 3. These are factor risk premiums. Right? For example, in case of KPM, we had RM minus RF. RM minus RF was the risk premium of the market. Right? Same way over here, beta 1, beta 2, beta 3 will be the factor risk premium. There, beta was like 1% change in market will lead to what percentage change in the return of the security. Here, beta means beta 1 may be, when we look at this beta 1, it may be like 1% change in GDP will lead to what impact on the return of the security. Beta 2 may be 1% change in the forex rate. What will be the impact on our security return? 1% change in inflation will lead to what percentage change in the required return of the particular security. So in this way, you'll have multiple betas, and every company is going to have different beta. Like for example, inflation. Do you think inflation will impact all the industries equally, or it will have varying effects? For example, I say that beta 2 is, let's say, inflation beta. Sensitivity of the security return with regards to inflation. So what do you think? Whenever there is an inflation, whenever the inflation numbers are out, whenever there are changes in inflation happening, what do you think about the impact? Will it impact all the industries equally? Will it impact all the industries, all the companies equally?
No.
No. Suppose I tell you there is a company which manufactures salt, and there is another company which is an airline company. Which industry or which company is going to be impacted to a larger extent due to rising inflation? Will the salt manufacturing company get impacted by inflation? Of course, no. Airline, right? Airline, hotel industry, they will be impacted by inflation. So you can say this beta 2 number is not going to be equal for all of them. It will differ from industry to industry. One industry may be very sensitive to inflation. The other industry may not be that sensitive to inflation. Same way foreign exchange rates. Which company would be obviously impacted by foreign exchange? Those companies which are heavily reliant on imports and exports, right? So whenever there is a change in the foreign exchange, the company which is purely into the domestic trading, everything is manufactured by the company in the domestic market, no forex exposure. Of course, the impact of foreign exchange on that company will be minimal as compared to a company which is into the foreign exchange trade or forex trade, right? And therefore, this model is actually breaking this particular security return into multiple risk premiums, we can say, right? Now, of course, implementing this model is a bit challenge. Theoretically, this model is very good, extraordinarily efficient model, sir, because we're trying to capture what all different risk a particular company faces. But when I want to implement this model, forming this equation is a difficult task. You cannot do it in pen paper mode. You need specialized software for that. And even after using softwares, it's difficult to implement this because even if you're trying to implement it, trying to know exactly what is the risk premium. Okay, we can get the betas anyways. Beta 1, beta 2, beta 3, we can get it easily. But calculating the risk premium is where the real challenge lies. Like in case of KPM, we said that risk premium is simply RM minus RF. But that's not the case in case of APT, guys, arbitrage pricing theory. Okay, so in case of arbitrage pricing theory, it's not the case because knowing what is the risk premium of a particular factor is difficult to estimate, right? And therefore, this model is yet to be into the practicality part. Okay, but yes, this model works maybe if you are just identifying two factors. Getting the values for just two factors is sufficient. More than two factors, it becomes a bit challenging. Okay, so that's the theoretical background for this arbitrage pricing theory. We will be given the values of betas and alphas, not alphas, betas of gammas, and just we need to apply it into the formula. Okay, let's look at the application of this arbitrage pricing theory in some of the numericals. Let's look at this question. Yeah. We have this. Question number 39. Let's look at this question 39. Mr. Nirmal Kumar has categorized all the available stocks in the market into following types. So we have like 4 stocks available with us, where we have the 4 types of stocks rather. We have the 4 types of stock with the weights given to us, weights in the market index. Factor 1 beta, factor 2 beta, factor 3 betas are given. Rate of return on treasury bonds is 4.5%. Now it's asked us, using arbitrage pricing theory, determine the expected return of the market index. Okay, using arbitrage pricing theory, what will be the expected return of the market index? Let me open it. Okay, so we have this question number 39. So we have 4 types of stock. One is a small cap growth, small cap value. A small cap growth. Then we have small cap value, large cap growth, and large cap value. Okay, so we know the weightages. Weights are given as like 0.25, 0.1, 0.5, and 0.15. Weights are given. Then we have factor 1 beta. So these are the 3 beta values given to us. So factor 1, 2, 3. Okay, so I've got the factor betas as 0.8, factor 1 beta is 0.1, 0.8, 0.9, 0.8, 0.9, 1.165, then it is 0.85, Factor 2 is 1.39, 0.75, 2.75, 2.05. Okay. Factor 3 is 1.35, 1.25, then we have 8.65 and 6.75. Okay, so these factor betas are given to us. We also know the risk premium of each of the factors. Risk premium of factor 1 is 6.85%. This is minus 3.5 and 0.65. Okay, so we have to use the arbitrage pricing theory to obtain the expected return on this. Okay, so for that, I'll need to get the factor betas of the portfolio, factor beta of the portfolio. So to calculate the factor beta, we'll say weight into factor 1 beta. So which will be simply weights multiplied by factor 1 beta. Right? And then we take a sum of it. Same way, we calculate the weights into factor 2 beta, which is weights multiplied by the second factor. We take this as again total. And then again weights into factor 3. So that is weights multiplied by factor 3. Right? And then we take the total of it. So we got these betas. So it's like portfolio beta. Portfolio beta is with regards to 3 factors, factor 1, 2, 3. So according to this model, first factor beta is 1, second factor is 2.105, and third is 5.8. So first factor beta is 1. So that is a weighted average number, and second factor and third factor same way, portfolio beta is okay. And then we have the risk premium, which is given to us as 6.85%, 3.50%, and minus 3.5 and 0.65. Now these set of values are nothing but beta 1, beta 2, beta 3. And what are these set of values? These set of values are lambda 1, lambda 2, and lambda 3. Okay, so now we know expected return of our portfolio. The expected return will be calculated as lambda 0 plus beta 1 into lambda 1 plus beta 2 into lambda 2 plus beta 3 into lambda 3. So the expected return using APT, expected return using arbitrage pricing theory, will be lambda 0. Lambda 0, what is the risk-free rate given to us? Risk-free rate is 4.5%. That is 4.5% plus portfolio beta 1 multiplied by risk premium of the portfolio, which is 6.85%. Then, so that we can add 2.105 into minus 3.5% plus 5.8 into 0.65%. So the expected return will simply work out to be 7.75% from the portfolio. So it's just 7.75% using the arbitrage pricing theory. We can say the return that is expected from a portfolio is 7.75%. Okay. Expected return using arbitrage pricing theory is 7.75%. Now, If you would have used like CAPM, expected return using CAPM, it will be just RF plus beta into RM minus RF. Right? So this is going to be like risk-free rate is 4.5%. Right? Risk-free rate is like 4.5%. Plus beta will be considered only of the market, which is the factor one is the beta. So this beta is the single beta that we are talking about. So the single beta is, of course, market beta is 1 multiplied by market risk premium is 6.85%. So that will give us the value to be 11.35%. So if you are using only purely CAPM, then we would say that we can expect we can expect 11.35% return. But in reality, 11.35% will be actually countered with this arbitrage pricing theory return of 7.75 because there is a negative risk premium for the second factor. So the second factor which is playing a role in determining return is actually dragging down your return using the APT. Okay, then Nirmal Kumar wants to construct a portfolio constituting only the small cap value and large cap growth. Okay, so we want only small cap value and the large cap growth. So this is what we want. If the target beta for the desired portfolio is 1, determine the composition of his portfolio. So if the target beta for the desired portfolio is 1, so what beta are we looking at? Of course, the first beta only. The second beta, it doesn't matter. Okay, so you want to create a portfolio of only small cap value and large cap growth. We know their betas are 0.9 and 1.165. And we want the beta, the factor 1 beta itself only, that should be equal to 1. Determine the composition of his portfolio. Now, composition of the portfolio means I want to know what should be the weights. Because I know the beta. Now, this will be weight multiplied by beta. We don't know what are the weights. So let me take this as, weight as simply W, and large cap weight will be 1 minus W. So weights into beta will be 0.9 W upon 1.165 minus 1.165 W. So what is the total? Total is 0.9 weights plus 1.165 minus 1.165 weights. And what should be this equal to? The weighted beta, weights into beta, what should be this equal to? The target value of this is 1. Right? So can you solve this and give me the value of W? Which will be, of course, small cap growth weight. What is the value of the W? You can just solve it and give me the value of weightage of small cap value. What's the value is small cap growth? Weightage should be 1 minus 1.165. One minus 1.165 divided by 0.9 minus 1.165. 0.622. Right? And then what will be the weightage of large cap value? That will be, of course, 1 minus weight, which is equal to 1 minus this, which is 0.3774. This should be the weightages to make the weighted beta equal to 1. Okay. That's it. Simple. Then let's look for this question 37. Mr. Tamarind intends to invest in equity shares of a company, the value of which depends upon various parameters as mentioned below. So again, there are 5 different factors. So there are 5 different factors. Let me put it then. Factors as the 5 factors are basically GNP, inflation, interest rate, then we have stock market index, and industrial production. So here we have these particular factor betas, which is 1.2, 1, 1.75, 1.30, 1.70, and 1. These are the factor betas. 37, yes, question 37. These are factor betas, and then they have given us the expected value and actual value. So expected values are like 7.70%, 5.50%. We have 7.75%, 10%, 7%. Actual values are 7.7, then 7%, 9%, 12%, and 7.50%. So these are the expected values and actual values. Now we know the betas. We have to compute, obviously risk-free rate is also given to us. The risk-free rate is 9.25%. Okay. So risk-free rate is 9.25%. We need to get the return of share under the arbitrage pricing theory. So under APT, we have to get the return of the share. So how do we get this return of the share under arbitrage pricing theory? Because what we have information in the question, this is the lambda 0. And these are the betas. We need to get the lambda values. So lambda values is basically nothing but the shocks, or the shocks that is generated. These are nothing but our lambda values. So another interpretation, which goes for this arbitrage pricing theory in a different way is, like you expected some return. You expected the inflation GNP to be growing at 7.7 or inflation to be 5.5. Inflation is 5.5. Actual value turns out to be 7%. So whatever is the shock or whatever is the change that is happening, that is the extra return that you want. Okay, that's the extra return that you want from that stock. So we take the shock value as simply the actual value minus the expected return. Right? So we calculate the shock or the extra return that we want, because if inflation is rising, my investors' expectation will also increase. When the interest rates are rising, I would also require a higher rate of return. When the stock market index is rising, I will require a higher return. If industrial production is rising, I expect a higher return, and if industrial production is reducing, then I will expect a lower return. So these are the lambda values. Now, expected return as per arbitrage pricing theory will be simply this 9.25% plus 1.2 beta multiplied by shock of 0% plus 1.75 beta multiplied by shock of 1.5% plus 1.3 beta multiplied by shock of 1.25% plus 1.7 beta multiplied by shock of 2% plus industrial production beta 1 multiplied by shock of 0.5%. Okay, so expected return as per APT will be 17.4%, taking into account all the lambda and the beta values. Okay, are we good till now, everyone? Yeah. Yes, everyone? Fine. So that is about this arbitrage pricing theory or APT. Now, we have the last tool under this portfolio management, which is called as portfolio performance measurement. Portfolio performance measurement. Now, you guys all are aware about mutual funds. You all are aware of mutual funds, right? Yes or no? Yes. How do we know? What is a mutual fund basically doing? It is simply taking our money and investing into multiple securities. And they claim that they are having a expert fund manager who is able to generate good returns for its investors. So how do we really know that the fund performance or the portfolio has been created in a better manner? Or how do we know that the portfolio is actually performing good or bad? For that, we have certain performance measurement tools, portfolio performance measurement tools. Now tell me, would you as an investor be interested only in the return that the fund is generating? Would you as an investor would be interested in just knowing the return that is being generated, or will you also give consideration to the risk? Yeah. What do you expect? The risk as well, right? Because blindly looking at return, it's not a rational thing. Then you fall into which category of investor? If you're going to blindly invest in a particular security, which category do you fall? No, not inefficient. I have stated 3 types of investors, if you can recall. In our last class, I have stated 3 types of investors. Can I say risk lover, risk neutral, or risk averse? If you're just looking for returns, looking only for the returns, you're interested in only the returns. Who you are? Are you a risk lover? Are you a risk neutral, or are you a risk averse? You are a risk neutral because you're looking only for return and not risk. And if you look only for risk, then you're a risk lover, right? So you should not be looking at only the return that a fund is generating. Rather, you should be looking for both aspects. Looking for both aspects as to risk and return both things. So there are certain performance measurement that we have. First one is Sharpe ratio. Then we have trainer ratio, right? And then we have Jensen's alpha. Sharpe ratio, trainer ratio, and Jensen's alpha. Okay, what is Sharpe ratio now? Sharpe ratio is computed as return of our portfolio minus market return. Return of our portfolio minus market return. Can you see this is the excess return that has been generated by the portfolio? Because in the market, if the overall market is giving, let's say 10%, and your portfolio is giving you, let's say 12%, in the market, the return is 10%, your portfolio is giving you 12%. So of course you have this risk premium, or this is the extra return that you're generating as compared to the market. This is the extra return that you're generating as compared to the market. Can I simply look at this number? Can I simply look at this number and say that my portfolio is performing good or bad? No. I need to check how much risk have I undertaken. I need to check how much risk have I undertaken, right guys? Yes or no? Do you think only the excess return should be looked at, or should it be in comparison with the risk also? Of course, it should be in comparison with the risk also. In fact, if I'm talking of risk, then I'll not consider the market return. I'll rather consider the risk-free return. Now, can I say return of my portfolio minus risk-free? This truly gives me what is the excess return that I have generated. Right? Suppose risk-free rate, government securities are giving you 6%, and your portfolio is giving you 12%, so double. But I would also like to know what is the risk that I have undertaken, and therefore we compute the risk-adjusted return, which is the standard deviation will be divided. So return of our portfolio minus risk-free, when you divide it by standard deviation, that's a Sharpe ratio, which gives us what is the risk premium for every unit of standard deviation. So risk premium for every unit of the standard deviation. Trainer ratio is computed as risk of return of the portfolio minus risk-free divided by beta. Okay, so trainer ratio is computed similar lines as the Sharpe ratio, but there we say we are going to divide it by beta. So this gives us the number of risk premium for every unit of beta. So for every 1 unit of beta, what is the risk premium that the portfolio has generated? Then there is Jensen's alpha. Jensen's alpha. Now let me explain you with the help of a number. Let's say return of market, or let me say return of market minus risk-free is, let's say, 4%. Risk-free rate is, so this is 4%. Risk-free rate is 6%. And you have a beta of, let's say, 1.2. Can you tell me what will be the CAPM return? What will be the CAPM return over here? CAPM return, what will be the CAPM return in this case? Tell me. CAPM return?
10.8%.
Okay, so it's 4% plus 1.2 into the market risk. Risk-free plus beta into RM minus RF. So that's like 10.8%, right? Now, if your actual return of portfolio is, let's say, 13%. So tell me, has the portfolio performed better, or has it been, below?
Better, sir.
The portfolio is performing better, right? So what is the additional return generated? Can I say additional return that is generated is 13 minus 10.8, which is 2.2%. And this 2.2% is essentially what we are talking of as Jensen's alpha. Okay, so talking of the Jensen's alpha will be return of portfolio minus CAPM return. To be very specific, we can say this is return of portfolio minus RF plus beta into RM minus RF. Okay, so that's the Jensen's alpha. So if we can say if Jensen's alpha, if it is, positive, if it is positive, it means portfolio has outperformed, right? If it is negative, what can we say about this? Portfolio has underperformed, right? And if it is 0, then we can say performance is at par. So if it is positive, portfolio has outperformed. If it's negative, portfolio has underperformed. If it is 0, then the performance of the portfolio is at par. Okay, so these are the 3 measures that we use to calculate the level of portfolio performance, or portfolio underperformance or overperformance. Okay, all the 3 measures are clear to you? Everyone?
Yes.
Yeah. Yes. Okay. Okay, so performance is determined based on this. Now, let's just apply this with the help of some questions. Okay, let's look at this question number 41. Yes. So we have portfolios A, B, C, D, E. Okay, so there are 5 portfolios given to us. Average annual return. So they have given us the return of the portfolio to be 19, 15, 15, 17.5, 17.1. Then we have the standard deviation. Standard deviation is 2.5, 2, 0.8, 2, 1.8. And then we have correlation with market. So we have correlation of the portfolio and the market. Correlation between market is 0.840, 0.540, 0.975, 0.750. Okay, then it is 0.6. So that's the correlation. We have been given additional information that market risk or standard deviation of the market. Standard deviation of market is 1.2. Market rate of return, like RM, is 14. The risk-free rate is given as 9. Okay, so now based on this, we can calculate definitely the risk-free rate, the Sharpe ratio, Trainer ratio, and the Jensen's alpha. So let's compute the Sharpe ratio. Sharpe ratio. As you stated, Sharpe ratio takes into account the return of the portfolio in comparison with the market, in comparison with the risk-free rate, and we divide it by standard deviation. So Sharpe ratio is computed as return of portfolio minus risk-free rate divided by the standard deviation. So it is return of portfolio minus the risk-free rate is 9 divided by standard deviation. So Sharpe ratio is calculated in this manner. Now, the rule for Sharpe ratio, as I stated, is higher Sharpe ratio. Okay, higher Sharpe ratio indicates greater risk premium for every unit of standard deviation. So based on Sharpe ratio, I can give the ranking. The first rank, the best performing portfolio as per Sharpe ratio is the 7.5 Sharpe ratio. So it's giving you better return for every unit of standard deviation that you have taken. The second ranking goes to, of course, portfolio E. Third ranking to portfolio D. Fourth ranking is to the portfolio A. And the last, portfolio B, is the worst performer of all of them. Then the next ratio that we have learned right now is called as a trainer ratio. Trainer ratio is also similar to Sharpe ratio. The only difference is instead of dividing it by standard deviation, we divide it by beta. Right. So we'll say return of portfolio minus risk-free rate of 9, and we divide it by beta. But where is the beta value, guys? Can I say we'll have to compute the beta first, right? So let us compute the beta for this portfolio. How do we compute the beta, by the way? If you can recall, beta can be computed as correlation multiplied with standard deviation of the portfolio divided by standard deviation of the market. Right? We know this formula, right? Beta is going to be correlation between security and market into standard deviation of security upon standard deviation of market. So that's what we're going to apply here. So we know the correlation number. We multiply it with standard deviation of security and divide by standard deviation of market, which is 1.2. So on the same lines, we got the beta numbers. Now, these beta numbers can be used to compute the trainer ratio, which is return of portfolio minus the risk-free rate of 9, and you divide it by beta values. So we got the trainer ratios also. Now again, based on this trainer ratio, we are going to rank the portfolios. So trainer ratio rank. The trainer ratio rank. Of course, the best performing is 9.23. So this will be given the first rank. Then the second best performing is the last portfolio. Third one is portfolio number 4. Then this is the fourth performing, and of course the worst performing is the first portfolio. So there is one commonality: 1, 2, 3 ranks are same. There's a difference between fourth and fifth rank. But yes, we are surely saying that portfolio C is the best performer as far as the Sharpe and trainer ratio is concerned. Then coming to the last part, which is Jensen's alpha. Now, Jensen's alpha can be simply computed as the return of portfolio minus risk-free plus beta into RM minus RF. Right? So, this is return of portfolio. So, we have the return of portfolio as 19. Right. From that, we are going to subtract the risk-free rate, which is risk-free rate is given as 9 plus beta of 1.75 multiplied by market return is 14 minus the risk-free rate. The risk-free rate is again 9%. So risk-free rate is minus 9. That gives us 1.25. So based on this, do you think that any of these portfolios had underperformed? Do you think any of these portfolios have underperformed as compared to the CAPM? No, sir. There doesn't seem to be, going for underperform. Rather, all of them are in the overperformance category because they are giving you return more than the CAPM return. But yes, if you want to give them rank as to which one has really performed outstandingly, then it's of course the last portfolio. Second rank will definitely go to the third. Fourth rank, third rank goes to the portfolio number 4, and then the fourth is for this, and the first one is the worst performer of all of them. Of course, it's giving you return more than your CAPM return, but compared to other portfolios, this has slightly underperformed. Okay, so that's how we calculate the Sharp, Trainer, and Jensen's Alpha, and then we judge which of the portfolios have performed better. Now, out of these 3 ratios, you can use all the 3 ratios in combination. You can take the total of ranks and then take a decision which of them are really performing. But there may be sometimes conflicting, conflicting results, not exactly conflicting, but a bit of diversion may be there because the performance matrix is different. Right? Since the performance matrix is different, the ranking may be different. But yes, we get a broad idea as to which portfolios are really performing good or which portfolios need to be performing in a more better way. Okay, so with that I am done with this particular topic of portfolio. We started with way back calculating expected return, and we have come a long way till here by looking at the performance tools for measuring the performance of the portfolios. Now it's turn for you. If you guys have any queries, you can definitely ask it. Yeah. Yeah, Brakesh.
Sir, Prakash. Sir, in the earlier example where you have compared Markowitz and Sharp.
Yeah.
In calculation, Markowitz, I mean, for last question in the assignment, I mean, the same number, I mean, all the parameters have been taken, or can you just go to that working, sir?
Which one? This one? As per Markowitz,
where we
as
have
per
compared.
Sharp?
Yes, this one, sir.
Yeah.
Where in this variance of Markowitz formula, we are considering all the factors, I mean, all the securities, or just 2 for the last question of the assignment?
No. We are considering all the 3 securities.
So, sir,
you can see we are taking covariance between A and B. We have taken covariance between B and C, and also covariance between A and C. Yeah, but what about covariance of B and C is what, sir? That's given in the question, B and C. 0.04. Yeah. Okay. That's it, taken over. Yeah, clear. Okay, fine. Thank you, sir. Okay. Yes, sir. Okay, thank you. Okay.
I think there are no more questions.
No more.
Okay, students. Well, we come to the end of the topic, portfolio management, and thank you, Jagbandhu sir, and especially I like in your initial session how you have differentiated between Markowitz model and Sharpe index model, and how you have beautifully you defined the formula that what is the significance of the error term. Okay, and how it is related to the unsystematic risk. It was wonderful. So I hope the student, you must have understood the logic behind almost all the formulas that has been covered in this chapter. And I think it will also help you to understand the formula, not to cram the same. Once you understand the logic behind the same, then you don't need to cram the same, and you can easily attempt the questions in your examination. Now, with this, we are going through with the topic of portfolio management. Now, in the next class, we shall start with a new topic. So, Jagbandhu sir, thank you very much for sparing your precious time and enlightening the student on this topic. And we also thanks the student for patient listening and responding to the and responding for the same, or we can say it is a both way interaction. So we help encourage you that you can ask your query during the session as well in the session, end of the session. Jagbandhu sir, just exhibit my email ID as well as my phone number so that any student have any query, they can send the same. Yeah. Okay, student, if you have any query, you can contact me at this telephone number, or you can send us the email, or you can also send your query through the BOS mobile app. So for the next topic, securitization, there are no such assignments will be are required to be uploaded. This is almost a theoretical topic. So it will be covered in the one class. Okay. So student, with this, see you in the next time, and revise whatever you have discussed in the previous classes. Thank you.
Sir,
Yes, yes.
I'm sorry. Is it too late to ask a question?
No, it's not.
No, you can.
Please ask your question, beta.
Sir, actually, I wanted to know. I was doing my calculations at home,
Hmm.
and during the class, the answer for the beta was 1.920.
Hmm.
But while I was doing it, the answer was 1.91. Is this much variation acceptable in the
Yeah.
exam?
Yeah. See, beta, now I tell you, it is a very good question. Now, thank you very much for reminding me about the same. See, sir, see, beta, in these classes, Jagbandhu sir has used the Excel model. Okay, he has used the Excel, but in your examination, you are not allowed to use the Excel model. So you need to carry out all the calculations on a simple calculators. Okay, even in the study material, most of the questions are based on the calculation of the based on simple calculator. So this much of variation will be there. Don't worry, this will be allowed. This much of variations are allowed.
Thank you, sir. Thank you, sir.
Okay, you don't need to worry about the same, because they are generally rumors like that. They normally detect the marks. There are no, if any instruction has not been given, say as I mentioned you, some hint has been given to you, you have to round off up to this decimal point. Otherwise, this much of rounding difference is allowed. No problem. Okay, beta.
Yes, sir. Thank you, sir.
Okay, thank you. Okay, beta. Okay, students, thank you very much, and see you in the next class. And thank you, Jagbandhu sir. Thanks a lot, sir. Yes, sir.
Yes.
Sure.
Thank you.